Welcome to the deep dive. Today we're going to really get into the work of someone whose ideas kind of shape our world every day, even if we don't always know it.
Yeah, that's right.
We've got some great sources here, articles from Islamicity, Wikipedia, thesmartmuslim.com, aboutislamstudy.com, Academic Block, and the New Arab. And they all point to this one figure, Muhammad ibn Musa al-Khwarizmi.
Absolutely. Al-Khwarizmi, a 9th century polymath, just an incredible mind. He lived roughly 780 to 850 CE.
Right.
From the Khwarizm region, that's modern-day Turkmenistan and Uzbekistan, parts of it anyway. And he worked in Baghdad at the House of Wisdom during the real peak of the Arab Golden Age, a time of amazing intellectual ferment.
Okay, so our mission here is to figure out why he's considered so important. I mean, what did he actually do, especially in math, that made such a difference? And how does it still affect us? Let's start with, well, the big one, algebra.
Indeed, algebra. His book, al-Jabr, which translates roughly to the compendious book on calculation by completion and balancing, written around maybe 820 CE, give or take.
Oh.
This book was really revolutionary. It wasn't just, a list of problems. It was the first systematic guide to solving linear and quadratic equations, basically setting out the rules.
It's the first systematic one.
Yeah.
So what was happening before? How are people solving these things? It sounds a bit messy.
It could be, yeah. There were methods in different cultures, but nothing quite like this unified approach. He showed, step by step, how to solve quadratic equations using completing the square.
Completing the square. I remember that from school.
Right. And he didn't just show how, he showed why. He provided geometric proofs for his algebraic methods. Imagine using actual shapes to prove the algebra worked. That logical underpinning was crucial.
So it wasn't just tricks, it was theory. And that's why he gets called the father of algebra. He didn't just solve equations, he built the whole framework.
That's a great way to put it. He treated algebra as its own subject, not just a helper for geometry or counting things, an independent discipline. And he introduced these core methods, reduction, that's basically canceling out the same things on both sides of an equation.
Okay, simplifying.
Exactly.
Yeah.
And balancing, moving terms across the equal sign, changing subtractions to additions on the other side. Stuff we take for granted now, but he formalized it.
It's amazing how fundamental that sounds. And the name itself, algebra, comes from his book title, Al-Jabr.
It does, yeah. Al-Jabr, meaning completion or rejoining, referring to that balancing step. The name of the whole field is basically a nod to his book.
That's wild.
And it wasn't just influential in the Arabic world.
Yeah.
Get this. In the 12th century, Al-Jabr gets translated into Latin.
Okay.
And it becomes the main math textbook in European universities for, centuries, right up until the 16th century.
Wait, centuries? Like 400 years?
Yeah, it had an incredibly long run. Think about how many generations of European scholars learned their mathematics from al-Khwarizmi's foundations.
Wow. So he didn't just invent it. His work was math education in Europe for a huge chunk of time. Okay, but you said he was a polymath. It wasn't just algebra, was it? There's something about our numbers, too.
Exactly. Around the same time, maybe 820 again, he wrote another book. In Latin, it became known as Algoritmo de Numero Indorum. Basically, al-Khwarizmi on the Hindu art of reckoning.
Hindu art of reckoning.
Yeah, it was all about the number system that originated in India, the decimal system, using digits 0 through 9.
Our numbers.
Our numbers. He was instrumental in introducing this system to the West, and crucially, this included the concept of zero.
Zero. It's hard to even imagine doing math without zero. How did they manage before? Roman numerals seem so clunky.
They were clunky. Roman numerals are additive, right? X is always 10, I is always 1. Their value doesn't depend on where they sit.
Right.
But the Hindu-Arabic system, al-Khwarizmi, championed. It's positional. The 1 in 10 is different from the 1 in 100 because of its position.
Yeah.
And 0 is the key placeholder that makes it all work.
It makes multiplication and division, possible in a practical way.
Infinitely easier, yeah. Try multiplying, say, CLX7 by XE9X using just Roman numerals. It's a nightmare.
Tuckles. Yeah, no thanks.
The positional system with 0 just streamlined everything. Calculation became so much more efficient.
And there's another connection here, isn't there? Something about his name.
Ah, yes.
Yeah.
The word algorithm and algorithm
Right.
both derived directly from his name, al-Khwarizmi. Originally, algorithm just meant the process of doing arithmetic using these new Hindu-Arabic numerals that he explained so clearly.
So the word algorithm, which is, absolutely fundamental to computers, programming, AI, everything.
Everything digital, yeah.
It comes from this 9th century scholar explaining how to do basic arithmetic.
That's the lineage. It evolved over time, of course, to mean any step-by-step procedure, but the origin, it's his name. It really shows how foundational his work was, providing the tools for things he couldn't possibly have imagined.
That's actually mind-blowing. The link between explaining arithmetic and, the code running your smartphone.
It is pretty staggering. But he wasn't just math. His interests were broader.
Right. The sources mentioned astronomy and geography, too. What did he do there?
Well, in astronomy, he compiled something called the Z as Sin Hind. This was the set of astronomical tables and calculations.
Okay.
And what's interesting is that it drew heavily on Indian astronomical methods, again, showing that flow of ideas between cultures. It helped refine calculations for the positions of the sun, moon, and planets.
So he was synthesizing knowledge, too, not just creating brand new stuff.
Exactly. Building on what came before, refining it. He also took on Ptolemy's geography, a classic work from ancient Greece.
Ptolemy, right. Very influential.
Hugely. But al-Khwarizmi revised and corrected it. His version, Kitab Surat al-Ard, or the image of the earth, provided much better coordinates for places across the known world.
Better coordinates.
Through more accurate calculations, observations, he was even involved in a massive project for the Caliph, al-Mamun, to measure the Earth's circumference and create a world map. Imagine organizing that in the 800s.
That's incredible ambition. So theory and massive practical projects. Did he work on smaller practical things, too? Tools?
He did. The sources mention writings on instruments like the astrolabe.
Ah, the astrolabe, that intricate device.
Yeah, vital for astronomy and navigation.
Yeah.
And also sundials for telling time accurately. Plus, he made contributions to trigonometry, producing accurate tables for sine and cosine, and supposedly the first tables for tangents.
Sine, cosine, tangent, essential for so much science and engineering.
Absolutely. These were practical tools derived from mathematical understanding.
So it's this amazing blend of pure math, applied math, astronomy, geography, instrument making. He really covered a lot of ground.
He truly did, a quintessential scholar of that golden age.
So pulling it all together, what's his lasting legacy? How should we think about his overall impact?
Well, I think you have to see him as this incredibly important link, a bridge, really. He took knowledge from ancient Greece, from India, synthesized it, added his own revolutionary ideas, particularly in algebra,
Right.
and then through those Latin translations we talked about, passed it on to medieval and Renaissance Europe, basically jump-starting a new era of mathematical development there.
And it wasn't just later historians saying this, right? Other big names in math and science recognized his importance.
Oh, absolutely. We're talking about giants like Carl Friedrich Gauss. Alfred North Whitehead called his work an invaluable heritage. Omar Khayyam, a brilliant mathematician himself, built on his work.
Wow.
George Sarton, a major historian of science, said al-Khwarizmi influenced math more than any other medieval writer.
Yeah.
And G.N. Watson was clear. He saw al-Khwarizmi as the founder of algebra, not just someone who collected old ideas.
That's some serious high praise from people who definitely knew what they were talking about.
It really is. It cements his place as truly foundational.
And it all loops back to that word, algorithm. From his name, explaining arithmetic, to the core concept driving our entire digital world today.
It's an extraordinary through line across more than a millennium. And as a little final tribute, there's even a crater on the far side of the moon named al-Khwarizmi.
Crater on the moon. Okay, that's pretty cool. A celestial nod.
A fitting honor, I think.
So let's just quickly recap. We've got al-Khwarizmi fundamentally establishing algebra as a discipline, giving it rules and structure with al-Jabr.
Check. The father of algebra.
And then he introduces the Hindu-Arabic numeral system, including 0 to the West, which completely revolutionizes calculation.
Check. Paving the way for, well, everything complex we do with numbers.
And his name gives us the word algorithm, the bedrock of modern computing and technology, plus contributions in astronomy, geography, trigonometry.
Yeah, a massive transformative impact across the board. Not just small steps, but huge foundational leaps.
It really makes you think, doesn't it? About how one person's work, one mind, over 1,000 years ago, can have such deep and honestly often invisible ripples through history, shaping the tools and ideas we rely on constantly.
Absolutely. Which leads to a pretty interesting thought to leave you with.
Okay.
How different would things be? I mean, really think about it. What if al-Khwarizmi hadn't done what he did in the 9th century? How might math look? How might technology have developed or not developed?
Hard to even imagine.
Right. And it makes you wonder what other absolutely fundamental parts of our world, things we take for granted, might have equally surprising origins hidden somewhere back in history, just waiting for someone to do a deep dive. Maybe that's a topic for another time.